Hello everyone, Mr. Minnick is my name, math is my game. Today I'm joined by my favorite Algebra 2 class. Say hi, class. When I say it's my favorite, it's probably a little early to pick favorites, but so far it is. We'll see if that holds throughout the year. Sorry about that camera noise if it's loud on the playback. So I'm going to cut each of these problems out, and one by one we're going to work through them. Number one says solve and check. So what I need to do is realize what this expression is really telling me is that the quantity negative 6x, the quantity negative 6x is 24 units away from 0 on a number line. Some of you might have realized when I set these up, I got to set up two equations. Yes, you do. And the reason for that is this. This expression here also says, this expression here also says that negative 6x is 24 units away from 0 on the number line, which has two different ways. We could go 24 units that way or 24 units that way. So the deal is we set up two equations. Negative 6x equals negative 24, so x equals 4. Negative 6x equals 24, so x equals negative 4. So our solution set is negative 4 and positive 4, or we could write that the answer is plus or minus 4. That's okay to write the answer that way. That's okay to write the answer that way. That's okay to write the answer that way. Any three of those ways is great. Those are the correct solutions. We could check them and plug it back in. Negative 6 times 4 is negative 24. The absolute value of negative 24 is 24. That checks out. And so does the other one. Questions about number one? Comments? Hopefully if you're watching back at home and you have questions, write them down. Come see me. So moving on to number two. If you missed the notes yesterday, the first thing that we should do is we should isolate, get by itself the absolute value quantity. So when I do that, what I'm going to have to do is something. I'm going to have to do something. I love my magic marker. It's my favorite on the smartboard. My magic marker, I'm going to be adding 4 to both sides of the equation, and of course 12 plus 4, I hope we know that that's 16. Okay. So like I did before, I'm going to set up two equations. One person in my one class this morning did this. They said, here's my one equation, here's my other one. I like that. That's not a bad practice to get into. So 2x plus 8 equals 16. 2x plus 8 equals negative 16. Word of caution here. Word of caution. Somebody that came in for some help with these said, you know, my one teacher said that we change that. We make that negative 2x minus 8. I don't know who's teaching you that, but that's wrong. You don't do it like that. Okay. So notice what's different here. The 16 and then the negative 16. Okay. The quantity inside the absolute value stays the same. Okay. So be real careful on those. So we get 2x is 8, and we get x is 4, and we get 2x is negative 24, and x is negative 12. So our solution set has a negative 12 in it and a 4 in it, and there we go. Both of those will check out if you check your work, and both of those are the solution. And I know what somebody's thinking. They're thinking, well, Mr. Minnick, that's sloppy. Yeah, it is. So what I'm going to do to check my answer is I'm going to go ahead and graph this. I'm going to go ahead and graph this. So I'm going to go to Desmos. It's a beautiful free graphing calculator, and I got to be careful how I punch this function in when I graph it. I'm going to be graphing the absolute value of 2x plus 8, but I want to have everything equal to y, and I'm replacing y with 0, so then I'm looking for zeros of the function. So the absolute value of 2x plus 8, there's a minus 4, and I need to bring that 12 over, and when I bring the 12 over, it's going to be a minus 12. So that's what I want to graph. Now I'm going to zoom out, and I'm looking for the x-intercepts, and hey, there's one at negative 12, there's one at positive 4, and there's my solutions. What do we think? Good? All right. So that takes care of number 2. Let's move right along. My window is, this window's messed up. Let me see if I can get that adjusted real quick. Oh, maybe not. Oh, well. So I'm going to look at number 3 next. In number 3, I am going to go and check my answers on number 3. Okay? So by now you probably realize we're going to set up two equations. X minus 2 is 4x plus 8. X minus 2 equals the opposite of 4x plus 8. Okay. I like to skip steps, but I don't like to skip too many. And there's a fine line between skipping steps and skipping too many. Okay. But anyway, I solve equations a little bit different than some of you probably do. I'm going to bring this x over here, so I'll get 3x. I'm going to bring this 8 over here, so 3x is going to equal negative 10. So I'm going to get x equals negative 10 thirds. Okay, x equals negative 10 thirds. I think. With this other equation, x minus 2 equals negative 4x minus 8. I need to distribute that negative through. Okay. So when I solve this equation, again, I solve equations a little bit different than some people. I'm going to bring this 4x over. So I'm going to have 5x equals, I'm going to bring this this negative 2 over. Negative 8 plus 2 is negative 6. And so I'll get x equals negative 6 fifths. So I get what I think are two solutions, right? How are we doing so far? Now, what I'm going to do is show you something about the TI Nspire that I really like. There's a lot of things that are good about the calculator, but this is something that's terrific, phenomenal. It's great. It's going to save you some time checking the work. You can actually use the calculator to solve an equation for you. Not that I would, because on Friday you're going to be taking a quiz, and I don't think you're allowed to use a calculator on that quiz. I'll have to check the directions. So here in a second, I'm going to use a calculator to check this. Actually, it's probably going to be about 20 seconds. While this is loading, are there any shout-outs? A shout-out to Mr. Jones. All right. Any other shout-outs? Travis Summers gets a shout-out. Any others? The school, the whole school gets a shout-out. Good. GHS. Good. All right. Okay, so what I'm about to do here on a calculator page is I'm going to take negative 10 thirds, and negative 10 thirds, and I'm going to go shopping. Some of you might know this about me. I live in Newton Falls, and it's pretty close to Warren. And I like to go shopping on the west side of Warren. You got to watch throwing up gang signs. But I'm going to go shopping on the west side. And they don't go to the store. You know where they go when they go shopping? They go to the stow. So I'm going to stow this as x. Okay? I'm going to store negative 10 thirds as x. And what I'm going to do now is I'm going to check to see if the statement is true with that value in there. So in the calculator, it'll tell me if it's true or false. So x minus 2. X minus 2 equals 4x plus 8 equals 4x plus 8. And if it's true, the calculator's going to say true. If it's false, the calculator's going to say false. And it says false. Well, wait a minute. I did all this work. Negative 10 thirds seems reasonable. Hopefully somebody remembers what we say about negative 10 thirds here. It's called an extraneous solution. We did really good work. And in the shell of our work, we got negative 10 thirds, but it's extraneous. It looks like a valid solution, but it does not satisfy the original equation. Here's a shortcut. I don't like to teach shortcuts, but here's a shortcut to look for. If one of your solutions, in this case the negative 10 thirds, if one of your solutions makes this quantity negative, the quantity is set equal to an absolute value, that's the extraneous solution. Okay. So you might say, well, what about the other one? What about the negative 6 fifths? Well, let's try that one. Let's try that one. Negative 6. Well, I'm having a hard time here today. Negative 6 fifths. I'm going to the stove. I was so excited about that. I said I'm going to the stove. Control variable, store that as x. And so let me try that again, and this time it's true. So negative 6 fifths does satisfy that equation. Okay. So just the negative 6 fifths is the solution. The other one's called extraneous. Okay. All right. Maybe we should look at this one on the graph real quick, huh? Real quick, let's graph it. We got the TI Inspire going, so let's go ahead and graph it on there. Doc, insert, we'll insert a graph page. So in absolute value, I said in absolute value, we got 2x, I think it was 2x plus 8, wasn't it? Oh, it's x minus 2. What am I thinking? It's x minus 2, and then we're going to subtract the quantity of 4x plus 5. When I graph that, I think I put in the wrong function. 4x plus 8. Thank you. Good looking out. 4x plus 8. That's better. So if I use a special set of eyes, I'm going to use my anal eyes, and I'm going to calculate the 0 of the graph. And the 0 of the graph is negative 1.2, which is negative 6/5. Okay. Decimals don't exist ever again. This is varsity math. Forget decimals. Okay. So that gets us up through 3. We got a long way to go. So I guess 4 is next. 4, it says solve and graph. Solve and graph. Inequalities, the cool thing about them is I can actually do some of the work before I do all the work. What I mean by that is I can graph my solution before I even get my solution. Because of this negative right here, I know when I make my number line, I know I'm going to have a tick mark here and a tick mark here, and I know I'm going to use open circles, and I'm going to be shading either between or beyond those open circles. What do we think? Between or beyond? I'm hearing beyond. I should be hearing between. We're going to be shading between these. We're going to be shading between these. Okay? So I'll be setting up 2 inequalities in a minute. I'm going to have 2x plus 2 in absolute value is less than 20. I get that by adding 5. So then I'm going to have 2x plus 2 is less than 20. And I need the word and here. I don't need it, but it's good practice. And 2x plus 2 is greater than negative 20. So a couple things to notice here. On this one, the sign changed and the sign changed. 2 things change when you set these up. If you're unsure why, what it comes down to is interpreting this expression right here. This expression says that 2x plus 2 is 20 units, less than 20 units away from 0 on a number line. That expression really says, if we had a number line, and here's 0, it says that 2x plus 2 is less than 20 units away. So somewhere in here, less than 20 units away, and it says 2x plus 20 is less than 20 units away that way. So that's kind of where those inequalities come from, and now we just need to solve them. Okay. So we're going to get 2x is less than 18, so x is less than 9. X is less than 9, so I guess I could plug a 9 in here. And then we'll get 2x is greater than negative 22, so x is greater than negative 11, and the negative 11 gets plugged in there, and that's that one. That's it. That's it. Anybody in this class get that one? Maybe we should look at this on the graph, huh? If we graphed the related function to this, got to do a little bit of magic on this one. Well, it's not really magic. I don't know if I believe in magic, but shout out to Jason Reby. He did a really cool magic trick the other day, card trick the other day. It was awesome. So if I made this a function, I'd have the absolute value of 2x plus 2 minus 20 is less than 0. And I would replace 0 with a y, so I'd have y is greater than the absolute value of 2x plus 2 minus 20. So I'm going to go ahead and graph that. I'm going to graph that and watch what happens. Watch what happens when I graph that. So I want the absolute value of 2x plus 2. Was that minus 20? Minus 20. And then I want y is greater than that. So here's the cool thing about the Inspire. You might say it's graphing an equation. It's graphing the function. Watch this. There used to be a rap song. I don't know if they still play it on the radio. What do they say? What's a big fine woman do? Use a big fine woman, won't you? Use a big fine woman, won't you? How's the rest of that go? Nobody's heard that song? Use a big fine woman, won't you back that thing up? Oh, yeah, that one. Use a big fine woman, won't you back that thing up? We're going to back that thing up, and it's going to be greater than greater than, so check it out. We don't see our other critical value, and that's okay. Maybe I should start this on a, oh, there it is. There it is. There it is. Okay, so notice on the graph, we're shading between 9 and negative 11, and that's it. What do we think? Yeah, good? Okay. All right, well, that gets us up through number 4. I guess we're moving on to 5. Moving on to 5. Moving on to 5. So on 5, we're going to solve it. We're going to graph it. I'm going to start up my graph. I know they're going to be solid dots here. Solid dots because it's or equal to. Because it's a greater than, am I going to shade between or beyond this time? Beyond, good. So I'm going to have some oars of a boat. I'm going to have some oars of a boat like that. And so I'll have two inequalities. 4x minus 6 is greater than or equal to 10. Notice the one inequality is the same. Nothing changes except the absolute value bars get dropped. The other one, we're going to write the word or here. The other one is going to be 4x minus 6. Remember, two things change, the sign and the sign. So less than or equal to negative 10. So we'll go ahead and solve these two. 4x is greater than 16, so x is greater than or equal to 4. So there's my 4 there. 4x is less than or equal to negative 4, so x is less than or equal to negative 1. So there's a negative 1 there, and there you have it. Did anybody have number 5? Good. Hopefully by now you get an idea how to do these. With all that information, you should be able to do the rest of the homework except for number 40. Number 40 is tricky. So number 6. We already talked about extraneous solutions. They don't satisfy the original equation. We did really good work. We come up with a viable solution, but it doesn't satisfy, it doesn't make true the original equation. Okay, I'm not going to write all that down. But an extraneous solution seems like a reasonable solution, but it does not make the original equation true. Okay. Number 8. Somebody had a really great answer for number 8 in my first period class. They just forgot to make it an inequality. It does say an inequality, okay? So on number 8, the deal is you want some kind of absolute value, whatever. Okay, it honestly doesn't matter what's in there as long as there's at least a variable x, okay? Maybe you have 4 minus x. It really truly doesn't matter. Maybe you have 2x plus 1. You can have anything as long as you have some kind of variable in there. Because it's an inequality, we could have a greater than or equal to. We could have a less than or equal to. That really doesn't matter. Now, if you want to make this real basic, that's good. But what has to go over here? What kind of number needs to go there to satisfy number 8? So that there's no solution. Anything negative, nice, good. Anything negative here would work. Negative 2, there you go. If you wanted to be a little bit more creative, you could say negative 5 times the absolute value x plus 1 minus 3 is greater than, in this case, this might be something, this could be 12, okay? That could be 12, because if you simplify that, then you get 15 divided by negative 5, which would be a negative 3. So you could get a little more creative, but that's the idea on number 8, okay? All right. So that gets us through 1 through 6 and number 8. I'm going to give a shout out to the people who were ambitious and did the whole thing or the whole front page. The margin at the top says 1 through 6, 8, and then 10 through 65 multiples of 5. So from here on out, we're just looking at multiples of 5. Any more shout outs before we start with 10? Mom gets a shout out. I'm going to give a shout out to the future Mr. Minnick. All right, number 10. Number 10, we're going to have 3x is 18. 3x is negative 18, so we get x is 6. X is negative 6. There you go. Two solutions. There they are. Bam. How are we doing with that one, all right? Good. Remember yesterday we said the answers, the solutions aren't always plus or minus the same thing. And maybe by the end of this we could sum up when they are and when they aren't. I love number 15. I love what somebody in the other class said about number 15. They started saying, okay, so we can add 3, but I think I did this wrong. And I said, well, yeah. And they said, well, my dad told me that it's no solution. I said, well, your dad's right. Guess what? It is no solution for a couple reasons. Number one, this is an absolute value quantity, and we said absolute values are distances. And distances are 7 miles, 6 inches, 5 feet, 10 feet, 1 inch. The ceiling in my room is 10 feet, 1 inch. Notice I didn't say negative 10 feet, 1 inch. It's 10 feet, 1 inch. So the deal is if we compare an absolute value to a negative quantity, it doesn't make any sense. If we graph it, if we were to try to graph number 15, what we would be graphing is this. We try to graph the absolute value of 2x minus 3. I said minus 3. And then plus 1. Notice what the graph looks like. The graph doesn't touch down on the x-axis. The solution of the related equation is where the graph goes through the x-axis. Well, it doesn't, so there's no solution. How are we doing? Okay. So number 15, it's no solution. No solution. Now, 20. We still solving on 20? Yeah, good. 20 we're solving. I mentioned that the calculator can solve these for you. I will warn you, the calculator will let you down. It's kind of like a really good friend. I had a couple really good friends growing up, but at some point they let me down. I needed them, and they let me down. But the calculator can solve this. Watch. I'm going to go to a calculator page, and I'm going to tell the calculator, oh, calculator, you're my friend. I love you. You're the best. You're the bomb. I better not say that. Numerically solve this equation for me, please. The equation that I want you to solve for me goes like this. The absolute value of 2z minus 3, 2z minus 3, equals 4z minus 1. Please solve that equation for the variable z for me. Now, I've got news for you. If you're using this on the TI Nspire CX, not the CAS, but the TI Nspire, it's only going to give you one solution if there are more than one. This could have 2 solutions, but the calculator is only going to give you one. If you're using this to solve quadratic equations, it's only going to give you one of the 2. And all quadratic equations have 2 solutions. We'll get to that in chapter 4. So here we go. The solution is 0.67. Now, I said decimals don't exist. So hopefully you can recognize what that solution is. 2/3. Good. I like it. I like it a lot. So z is 2/3. That's the only solution to that. Maybe the calculator let us down. Let's see. Let's see. 2z minus 3 is 4z minus 1. So 2z is negative 2, and z is negative 1. Wait a minute. The calculator only gave me one solution. But wait a minute. Didn't the directions say check for extraneous solutions? So if I check, I'll get 2 times negative 1 minus 3, all that in absolute value. Is that equal to 4 times negative 1 minus 1? So that's the absolute value of negative 2 minus 3. That's the absolute value of negative 5. Is that equal to negative 4 minus 1? Is that equal to negative 5? Is it? No, it's not. No. No. So what we say is this is extraneous. Okay, that's an extraneous solution, so it's not really a solution. So where's the other one come from? I don't know. Maybe we pull it out of thin air. Maybe 2z minus 3 is the opposite of 4z minus 1. Be careful when you do that, okay? Notice I put the opposite of that quantity, so I'm going to distribute my negative 2z minus 3 is negative 4z plus 1. So 6z is 4, and z is 2/3, because 4 6 reduces to 2/3. Okay. So the calculator actually won that battle. 2/3 is the solution to that one. Any questions, comments, concerns, short debates about number 20? About any of these equations or inequalities in general? There's a comment that we're so lost. If you missed on yesterday, you would be well served to look at the 1.6 notes on solving absolute value equations, and those can be found on my YouTube page. So, all right. So I guess we're on to 25. On to 25. We didn't get a chance to see this one in the other class, but I really like this one. Solve and graph. Solve and graph. So kind of like I did before, I'm going to set up my number line. Open or closed circles? Open circles, good, because it's not equal to. Shade between or shade beyond? Shade between, nice, we're getting it, we're getting it. So I'm going to divide by 3 before I do anything. The absolute value of y minus 9 is less than 9. So I'm going to set up 2 inequalities. Y minus 9 is less than 9. Y minus 9. Remember, 2 things change. 2 things change, the sign and the sign. So not less than, but greater than negative 9. So I'll get y is less than 18. So here's 18. And I get y is greater than what? 0. There we go. There it is. If you're ever not sure, you think you might have messed up, check an alternative method. Go to the graph it. Now, some of you, I don't know how much I've commented in any of my classes about this. Some of you are using, I call it a resource. Some people might call it cheating. It's a resource, okay? I'm not going to say don't use resources, but what I am going to say is that sometimes we get too dependent on something. Some people are chemically dependent. People when they get addicted to drugs and or alcohol. Some people are mathway dependent. When they get addicted to using mathway to get the answer for the sake of getting the answer. I'm not saying don't use mathway. I'm saying don't use it for the sake of getting an answer. Okay. So on mathway, if I enter the problem, it's 3 times the absolute value of y minus 9, and then that is strictly less than 27. Mathway says, do you want me to convert to interval notation? No, that's not what I want, Mathway, so you're not as intuitive as you used to be. Solve for y, yeah. Graph, yeah. So maybe I want to solve for y first. Solve for y. So Mathway writes y between 0 and 18, which is actually the right way to write that. Y is between 0 and 18. And then let's see if Mathway can graph this for us. Mathway, can you graph this for us? Can you graph this for us? Well, it gave us a table, and I don't know. I don't think that's going to get that done. So Mathway's not always going to give us everything we want. Maybe does it have an option to plot on the number line? Plot, or yeah, I don't know. It's not the kind of answer we're looking for, is it? Okay. So even Mathway has its drawbacks, its limitations. Okay. So I guess that gets us up through 25. We're looking at 30 next. We got 2 more on this front page, and then we'll go to the back page. So number 30. Some people, when they see one like 30, they say, oh man, there's too many numbers there. Oh, there's too many numbers. Big deal. It's the same thing. Get the absolute value stuff by itself. So I'm going to have 3 times the absolute value of 5. I'm going to make those t's caps if you don't mind, because my t's look like pluses. So 5t minus 1, that's going to be less than or equal to 14. Oh. I smell fractions in our future. I smell fractions in our future. Oh, man, this is going to get nasty. So 5t minus 1 in absolute value is less than or equal to 14 thirds. Anybody make it that far and then just kind of stop? It happens. It happens. We will be spending time in class going over fractions, how to add, multiply, subtract, divide them, because it's critical that you can work with fractions. Okay, so here's my number line. I don't know what these things are going to be. They're probably going to be fractions. Solid or open dots? Solid dots, shading between or beyond? Shading between. So my final answer is going to have t is less than or equal to something is less than or equal to something. Okay, if I'm using words, I'm using the word and. I'm going to use the word and. So here we go. 5t, take away 1 is less than or equal to 14 thirds. At this point, I want to change, well, I'll go ahead and write my other inequality. 5t take away 1 is greater than or equal to negative 14 thirds. And here's my conundrum. Here's my hang up. 1, I can't add 1 to 14 thirds nicely. Who can read my mind and tell me how I'm going to rewrite 1? I need to write it in terms of thirds. So I'm going to rewrite that as, it's going to become 17 thirds, but I'm going to make, 3 thirds. I'm going to turn that 1 into a 3 thirds. I'm going to turn that 1 into a 3 thirds. So we're good. We got the right idea there. Good. So I'm going to get 5t is less than or equal to 17 thirds. I'm going to get 5t is greater than or equal to negative 11 thirds, I guess. And when you divide fractions, so we divide by 5. When you divide fractions, it's like multiplying by their reciprocal. So I'm going to multiply by a fifth, divide by 5, multiply by a fifth. So what I've got here, the 5's cancel. I get t is less than or equal to, it's numerator, denominator, denominator. It's going to be 17 fifteenths. And t is greater than or equal to negative 11 fifteenths. So greater than negative 11 fifteenths, negative 11 fifteenths, but less than 17 fifteenths, less than 17 fifteenths. Improper fractions are awesome, yeah. The question is, how did the 1 become a 3 thirds? So to answer that, let's kind of think about this. Let's think about 6 plus 3/8. Okay, we could write that as a mixed number, 6 and 3/8, but suppose we need to do something with it later. Mixed numbers aren't nice to multiply and divide and that kind of thing. So the deal is, we would need to turn this 6 into some number with respect to the same denominator, okay? So to transform 6, what we do is we would multiply it by 8/8. If we think about 8/8, this is the multiplicative identity. It's equal to 1. If we multiply something by 1, it doesn't change its value. So when we do that, we would have 8 times 6, which would be 48, over 8 times 1, which would be 8. So if that doesn't make sense now, we will spend some time down the road on fractions. Okay? I don't know if that answered your question right now, but okay. So that's that one. That's probably the second worst problem on the homework. How are we doing so far? Okay. Well, we got 35 and then we're on the back. 35 and then we go to the back. I always like cutting these out like that. Set my page background. I'll go old school, make it a chalkboard. How's that? Hopefully this will show up in the video. That red dot's driving somebody with OCD nuts, so I'll get rid of that. And I guess I'm going to need a white marker. I feel like Blake Shelton when I say that. I'm going to need a white marker So here we go. The absolute value of 2x minus 1 is greater than or equal to 7, right? So I'm going to have a number line, open or closed dots here. Closed, shading between or beyond. Shading beyond, shading beyond. So we'll have 2x minus 1 is less than, or I'm sorry, greater than or equal to 7. So 2x is greater than or equal to 8. X is greater than or equal to 4. And then if I'm using words, I want the word or. 2x minus 1 is less than or equal to negative 7. 2x is less than or equal to negative 6. X is less than or equal to negative 3. Anybody have that one? That one wasn't so bad, was it? Okay. Well, that takes us up to number 40. I'll be honest with you, 40, we didn't go over how to do it in class. If anybody came up with 40, I would be most impressed if they came up with it on their own. Does anybody in here think they have it? What do we got? I'm sorry, what do we got again? Between 52.5. Well, 52.5 comes into play. And there's something else that comes into play. A 2.5 comes into play, right? We think we got it? Compound inequality? Okay, so here's the deal. On this one, we're going to write an absolute value. We're going to write a b. We're going to write an absolute value. We're going to write a less than or equal to. And we just got to figure out which number goes where. Which number goes where? There's going to be a minus here. So we're either going to plug in the 52.5 here, or we're going to plug it in here. And I'll be honest with you, I always forget which place it goes. I really do. Let's just try it in here and see what would happen. If we had it in there, what we would end up with is b minus 52.5 is less than 2.5, which would make b less than or equal to 55. So that looks good so far. That looks good so far. The other one would be b minus 52.5 is greater than or equal to negative 2.5, and that would be b is greater than or equal to 50. So that's it. There you go. There you go. That's it. Might want to make a note of that one. Find the median. Put the variable, take away the median in the absolute value. In that particular case, less than or equal to the 52.5. 52.5 is the median of 50 and 55. That one's tricky. There is a question, not exactly like that, but there's a question like that on the pre-assessment. Remember the one about the absolute or the inequality? Write an absolute value inequality. Okay, and we'll talk about that throughout the year. So that's 40. Hopefully we could finish this in the time that's left here. So 45, this ought to go pretty fast. 45, we're solving. 3x minus 1 in absolute value equals 15. So 3x minus 1 is 15. So 3x is 16. X is 16 thirds. 3x minus 1 is negative 15. 3x is negative 14. X is negative 14 thirds. Yes, question. Did I just, so the question is about 16 divided by 3. 16 thirds is improper. It's an improper fraction. It's fine. In varsity math, you could make this 5.3 repeating. That's okay. But if you wrote that x is exactly equal to 5.333, that's wrong, and I will mark it wrong on a test. Yeah, I just put the 16 over 3, and that's okay to leave it like that. If it reduces, we should reduce it. But otherwise, improper fractions are good. Good question. And actually, that came up on the pre-assessment, too. And we'll talk more about that in the future. So we got a couple more here. 50 is next. And that just totally picks that up. That's okay. 50, where'd you go? 50. There you are. Oh, 50 kind of looks scary. If you see that 6 in 50, you got to realize, let's divide by 6. Let's divide by 6. The absolute value of 2x plus 5 equals x plus 4. So 2x plus 5 equals x plus 4. 2x plus 5 equals negative the group of x plus 4. So x equals negative 1. 2x plus 5 equals negative x minus 4. So 3x is negative 9, and x is negative 3. And both of those solutions check out. If you graph this, both of them check out. There are no extraneous solutions. They both work on this one. Okay. That's 50. We got 2 more. 3 more. I don't know if we'll have time to get to them. 55, it's the absolute value of x is strictly less than 4. Anybody come up with that one? That one was pretty easy, I think. For sake of time, I'm just going to read off the answers to the last ones. Number 60. Number 60, we're going to have t is less than or equal. I'm sorry, less than negative 3 halves. 60, we're going to have t is less than negative 3 halves. T is less than negative 3 halves. T is less than negative 3 halves, and t is greater than, anybody have this? The other one? 2, good. T is greater than 2. That's an open circle. Open circle. T is greater than 2. And finally, 65, it's between, you'll have negative 5 is less than x is less than 11. Negative 5 is less than x is less than 11. That's it. It's been real. It's been fun. Again, if you have questions that I didn't answer in this, please see me. Third period's my planning period. Before school, after school, shoot me an email. It's been real. It's been fun. One last chance for shout-outs. Zach Smith. And that's it. See you next time.